Hello everybody, my name is Nader Zare. I'm member of Zare Soccer Simulation 2D team. In this video, I would like to explain the observation model of Soccer Simulation 2D server. Also, I will explain the proposed model of observation for the next version of the server. Soccer Simulation 2D League is one of the oldest league in RoboCup competitions. In Soccer Simulation 2D League, we have a server called RCS server. Players, coaches should connect to the server to have a communication with server and send comments and receive observation or information from the server. And there are some applications such as Soccer Window, RCSS Monitor, and Like Player to show what happened in the game. Each game takes 10 minutes or 6,000 cycles. So each player can receive 6,000 observation and send comment in the 6,000 cycles. The observation model in server version 17 contains three different view angles: wide angle, normal angle, and narrow angle. For example, if the player selects narrow angles, so the server will send the information, players or balls or flags in this area. I will talk about the view angles and the difference of them in the next slides. But now I would like to talk about 5 different observation areas that observer player can receive information from them. I'm calling them area A, B, C, D, and E. As you see in this picture, 4 of the observation areas are in the view angles of the player. So the first one is A, and the maximum distance to player is 20 meter. The second one is B, and the distance is 40. The next one is C, and the maximum distance in this area is 60. And if the distance of the object to the player is more than 60, so the object will be in area D. Also, if the object is not in the view angle of the player and the distance of the object to the player is less than 3, so the object is in area E. Also, there are 3 different types of message that the observer can receive from server. In the first message, the observer can receive uniform number, team name, velocity, and position by using the distance and direction from the observed object to the observer. In the next one, the observer can receive team name and position, and in the third message, the observer will receive just the position. For example, if the object, object player is in area A, so the server will send the unum, team name, velocity, and the position. But if the object is in area B, sometimes the server sends unum and velocity, and other times the server just sends the team name and position. And for the area C, the player sometimes send team and position, and the other time the server just send the position of the observed object. And if the object is in area D, area E, the server just sent the position of that object. In the current version of the server use send high flag, send high ball, send high player, and serialize high line functions to send the observed object to the observer. So now I would like to talk more about the view angles. As I mentioned, there are 3 types of view angles in the Soccer Simulation 2D server: wide, normal, and narrow angle. Also, there is a variable called visual send count in the server for each players. The visual send count variable shows that how many cycles the observer didn't receive any information from the server. For example, for the wide angle, if the send count is more than or equal to 3, so the server will send wide angle information to the observer if the observer requested to receive information of wide angle. Also, as you see here, if the send count is more than 2 or equal to 2, the server can send information of normal angle, and if the send count is equal to 1 or more than 1, the server can send information of narrow angle. So in this table, there are 4 rows, and the first row shows the cycle number. The second one shows the view angle that player requested in the previous cycle. SC means send count, and send means the server sent the information or not. For example, here in cycle 3, the observer send a command to the server by using change view, and it requested to change the view to narrow angle, and the value of send count is 1 if the server wants to start a new cycle. So for example, here the send count of this player is 1, and the player requested narrow view angle, so the server sends the information to the observer and change the send count to 0. So in the next cycle, I mean cycle 4, the player asked to change the view angle to normal angle, and the send count is 1. So the player, as I mentioned here, doesn't send any information to the player. In the next cycle, I mean cycle 5, the player asked to receive information of normal angle again, and the send count is 2, so the server will send the information to the player and change the send count to 0. And in the next cycle, the send count will be 1 again, and the player requested a wide angle view, so the server doesn't send any information. And as you see in cycle 7, the player requested normal angle information, so the server will send the information because the send count is 2 here. For example, in cycle 10, the player requested wide angle information, and the send count is 3, so the server changes it to 0 and sends the information. In cycle 11, the observer requested wide angle again, but the send count is 1, so the observer doesn't receive any information. In cycle 12, the player requested narrow angle because the send count is 2, so the server will change it to 0 and send the information. Actually, here in cycle 12, the player could use normal angle instead of the narrow angle, because it could receive more information from the normal angle to the narrow angle. In this slide, I would like to talk about noise and explain how the server add noise to the information and then send it to the observers. The server uses an algorithm called quantization. As you see here, the server uses calquantDist to send the information of ball and information of other players, and in this function the server uses quantize function, and you see this function here to change the distance between the observer player and targets. Targets can be ball or can be other players. And in these two plots, you can see how much noise the server will add to the distance of the observer and the targets. And here, for example, if the distance is less than 20 meter, so the noise is less than 1 meter, as you see here. And if the distance between the observer to the target player or the ball is more than 80 meters, so the noise can be more than 4 meters. And in the right plot, you can see how much the server changed the distance by using the quantization algorithm. In this slide, I would like to talk about the algorithm of the server and explain how the server sends the observation to the players. In each cycle, the server receives comments from the players and coaches. After that, the server changes the positions, velocity, direction of ball or body angle of the players or neck angle, and after that the server will shuffle the players and start the send visual for each of the players. For example, here we have observer X, and the server will call the send visual function for the observer X. In the first step, the server will increase the value of send count, and after that it checks the send count and the visual interval, as I mentioned here. For example, for the wide angle, the visual interval is 3, for the normal is 2, and for the narrow angle is 1. In the next step, the server will send the flags, after that sends the ball, and after that the server sends the information of players. For example, here we have two players, player Y and player Z. So the server will call the send hi player function for the player Y. If the player Y is in the view angle of player X, so the server will find which information should send to the observer X, and after that it adds some noise to the information. Also, if the target players, that's player Y here, is not in the view angle, the server will check is the player Y close to the player X, and their distance is less than 3. So the server find the information, as I mentioned here, the position of the target, and add the noise, and the server after that will send the information to the observer X, and after that the server starts to calculate the observation for the player Y and player Z and other players. Now I would like to talk about proposed new observation model, and maybe you can see the new model in the server version 18. In the new proposed model, we wanted to add the team name to all of the observation areas in the view angle of observer. We wanted to change the view angle intervals for all of the three different view angle to 1. Also, we wanted to increase the noise depends on the view angle, and we wanted to add focus point in the observation model. As you remember, we had 5 types of areas, and we had 3 types of messages that a server can send to the observer. But in the new model, we will have 4 types of the messages. So as you see here, if the target player is in the view angle of the observer, the server will send the team name to the observer. But if the target player is in the area E, the server does not send the team name. as you remember, in the server version 17, the interval of each angles are different, 3, 2, and 1. But in the new version of the server, we want to change all of them to 1 instead of 3, 2, and 1. In the server version 17, when the server wants to send the information of players or ball to the observer, it uses the Q step to calculate the quantized distance, and the Q step is 0.1 in the server. And as you remember in the previous slides, uh, this plot shows the noise, and this plot shows the new distance of the observer to the target. But in the new version of the server, we would like to use 3 different Q steps to calculate the quantized distance. For example, we want to use 0.1 for the narrow angle, 0.2 for the normal, and 0.3 for the wide angle. And as you see here, by increasing the Q step, the noise will be increased. So in the new version of the server, the observer can receive the observation information in all of the cycles by using narrow angle, normal angle, and wide angle. But if the player uses the wide angle, the noise can be more than narrow angle. Now I would like to talk about the focus point, and it's the most important things that I've proposed in the Robocop meeting. As you know, the agents can send some types of message or comment to the server. For example, one of them is dash by using the power, or dash by using the power and direction, or sending same message turn neck or turn. Here we added a new message that agent can send to the server, and it's called set focus. It contains distance and angle. So by using this new command and setting the focus point, for example here the focus point is the orange circle, the noise will be increased by increasing the distance between the target and the focus point. For example, here in this picture, the noise of circle target is less than the noise of red circle in the received observation information. To set the focus point, the agent should send a command containing distance and angle. The dist value is the distance between the focus point to the current position of the player, and the angle is the difference angle between the neck angle of the player to the angle of the player to the new focus point. So, for example, if the agent wants to set the focus point to the orange circle, it should send the command by using the difference angle like this one, and the different distance, the distance between the focus point and the player. And in the next cycle, the server will change the focus point to the orange circle here. And in the implemented model, if the player doesn't send the set focus command, so the focus point will be the position of the player. Also, if the agent send the set focus command to the server and requested to set a focus point to a new point that is not exist in the view angle, the server will change the position of the focus point. For example, here the player requested to focus on the pink circle, but the pink circle is not exist in the view angle, so the server will change its position to the orange circle as you see here. And in this slide I would like to talk about a new function that we added to the into the server, and it's called calquantDist by focus point. This function, instead of receiving this to player and queue step, will receive this to player, this to focus point, and queue step. Calculate the noise distance in the first step. The server will quantize the distance of the target to the focus point. For example, here the distance to the focus point is 15. The server will quantize the focus distance, and the result is 12. So as you see here, the different distance between the dist to focus point and quantized focus dist is 3. So the server will change the distance to the player from 20 to 17. I hope this presentation could help you to understand more about the observation model of the current server and the new idea. If you would like to see the source code of the RCS server, you can find it here in this address. Also, if you would like to see the implemented observation model, you can check this link. And to get more information about the SS2D League, you can check this address. And if you would like to see our works in Cyber Soccer Simulation 2D team, you can check this address as well. And finally, thank you so much for your attention.